Have you ever wondered why some software is so intuitive and easy to use, while others leave you scratching your head? Or have you ever pondered how those world-changing technological innovations are born? In today's tech-driven world, we seem to view programmers as a group of tech geeks who just sit in front of computers typing code. But what if someone told you that the best programmers are actually more like artists? Would you believe it? Paul Graham presents this surprising perspective in Hackers and Painters. He breaks the stereotypical image of programmers, comparing them to artists. This unique viewpoint makes us wonder, what exactly connects these two seemingly unrelated groups? Is there really some mysterious link between programming and painting? Let's delve into this book together, explore the shared world of programmers and artists, and see how it changes our perception of technology and innovation. Part 1. Let's look at the commonalities between hackers and painters. Hackers, whom the author considers programmers, and painters, although engaged in seemingly different fields, actually have many similarities. Both possess the essence of. Have you ever wondered why some software is so intuitive and easy to use, while others leave you scratching your head? Or have you ever pondered how those world-changing technological innovations are born? In today's tech-driven world, we seem to view programmers as a group of tech geeks who just sit in front of computers typing code. But what if someone told you that the best programmers are actually more like artists? Would you believe it? Paul Graham presents this surprising perspective in Hackers and Painters. He breaks the stereotypical image of programmers, comparing them to artists. This unique viewpoint makes us wonder, what exactly connects these two seemingly unrelated groups? Is there really some mysterious link between programming and painting? Let's delve into this book together, explore the shared world of programmers and artists, and see how it changes our perception of technology and innovation. Part 1. Let's look at the commonalities between hackers and painters. Hackers, whom the author considers programmers, and painters, although engaged in seemingly different fields, actually have many similarities. Both possess the essence of creators. The most fundamental commonality between hackers and painters is that they are both creators. They don't just execute predetermined tasks or copy existing works, but are constantly creating new things. Hackers create software and applications through writing code, while painters create visual artworks through painting. Both strive to create excellent and beautiful things, and this creative process is at the core of their work. In the process of creation, both hackers and painters need to use their imagination and creativity. They not only need to solve technical problems, but also consider how to make their work more elegant, beautiful, and practical. This creative thinking makes their work far exceed the scope of simple technical implementation or mechanical replication. Secondly, the process of iteration and improvement is also very similar. Another important commonality is that both hackers and painters perfect their work through constant iteration and improvement. Painters usually start with a sketch, gradually adding details, adjusting composition and colors until the final work is completed. Similarly, hackers also start from an initial code framework, constantly debugging and optimizing until the software achieves the expected functionality and performance. This iterative process requires both hackers and painters to have patience and perseverance, to be able to accept the imperfections of their initial work, and to have the courage to constantly modify and improve. They need to maintain a critical attitude towards their own work, constantly looking for areas that can be improved. This spirit of pursuing perfection is a common trait of both. The process of learning and drawing inspiration is also very similar. Both hackers and painters improve their skills by learning from and drawing inspiration from the works of their predecessors. Painters study the works of masters and imitate their techniques to improve their painting skills. Similarly, hackers read excellent code and learn from its design ideas and programming techniques to enhance their programming abilities. This learning process is not just simple imitation, but requires a deep understanding of the essence of previous works and developing one's own style and innovation on this basis. Through continuous learning and practice, both hackers and painters can gradually form their own unique creative styles. When discussing how hackers and painters wholeheartedly engage in the creation of beauty, the author uses a painting by Leonardo da Vinci as an example. In this painting, titled Portrait of a Woman, there's a cluster of branches behind the girl's head. Da Vinci meticulously painted every leaf on the branches, even though they're just background details that perhaps no viewer would scrutinize. But, just as excellent paintings must go beyond what's necessary, excellent programs should do the same. When writing code, hackers often invest a lot of effort in polishing details that users might never notice, like those inconspicuous leaves. Although users may not pay attention, all these unknown details come together to create a stunning overall effect, just as millions of tiny voices sing out a heart-stirring chorus. This example vividly illustrates the commonality between hackers and painters in their pursuit of aesthetics. They invest time and energy regardless of cost, tirelessly polishing every detail of their work, all to create a flawless masterpiece. Part 2. Let's understand the qualities that the author believes good program design should possess. In Hackers and Painters, Paul Graham delves deep into what constitutes good program design. He believes that good program design is not just about technical excellence, but more importantly, it should be able to meet users' needs and have good readability and maintainability. Good program design needs to be user-centered. Good program design should first and foremost be user-centered. Programmers need to have strong empathy and be able to think from the user's perspective. An excellent program should be intuitive, easy to use, and meet user expectations. This means that programmers should not only focus on implementing the program's functions, but also consider the design of the user interface, optimization of operation processes, and other aspects. Good programs should be self-explanatory, allowing users to understand how to use them without detailed instructions. If a program's usage doesn't align with most users' expectations, even if its functionality is powerful, it's hard to consider it a good program. Programmers need to constantly ask themselves, if I were the user, how would I want this program to work? This user-centered mindset is key to designing excellent programs. Good program design needs to be concise and elegant. As Einstein said, everything should be made as simple as possible, but not simpler. Good programs should implement the required functionality with the most concise code, avoiding unnecessary complexity. Concise code is not only easy to understand and maintain, but can also improve the program's efficiency. Elegant design often solves the most complex problems with the least amount of code. This requires programmers to have a deep technical foundation and creative thinking, able to find the most elegant solutions. Speaking of the characteristics of excellent program design, the author uses ViaWeb, now Yahoo Store, as an example. ViaWeb allows merchants to set up online stores, an idea partly inspired by the hacker community's tradition of setting up personal homepages. ViaWeb's innovation lies in combining this tradition with emerging e-commerce. This practice of combining existing ideas from different fields in novel ways is precisely a typical feature of excellent program design. ViaWeb's design and development also embody the concept of considering from the user's perspective. To cater to merchants without technical backgrounds, ViaWeb's interface design is as simple and intuitive as possible, while the back-end code considers different users' bandwidth conditions, striving for quick response. This empathy of thinking from the user's standpoint is an indispensable element of excellent program design. ViaWeb's success shows that innovation doesn't necessarily come from completely new inventions, but from cleverly utilizing existing resources and providing thoughtful solutions from the user's perspective. This case perfectly illustrates the essence of program design. Part 3. Let's see what the author believes is the essence of innovation. In Hackers and Painters, Paul Graham conducts an in-depth discussion on the essence of innovation. He believes that true innovation doesn't come from sudden bursts of inspiration out of thin air, but from a deep understanding of existing things and continuous improvement. Firstly, the author believes that the essence of innovation is often gradual improvement rather than sudden revolutionary changes. True innovators are usually those who deeply understand existing systems and can see opportunities for improvement. They achieve breakthrough innovations through constant trying, failing, learning, and improving. This gradual innovation process requires innovators to have patience and perseverance. They need to be able to accept initial failures and learn from them. Each small improvement could be a stepping stone to a major breakthrough. This view challenges the traditional perception of innovation as a moment of genius inspiration. Graham believes that most seemingly revolutionary innovations are actually the result of long-term accumulation and improvement. Innovators need to have the ability to identify problems and limitations in existing systems and the courage to try new solutions. The author believes that innovation requires thinking outside the box. True innovation often requires stepping out of existing thinking frameworks. Innovators need to have the ability to question established assumptions and look at problems from new angles. This ability often comes from broad knowledge and experience, as well as cross-understanding of different fields. Graham emphasizes that innovation is not limited to the technical field. Innovation in business models, user experience, organizational structures, and other aspects is equally important. Being able to combine knowledge and experience from different fields often leads to unexpected innovations. Finally, innovation needs to solve real problems. Truly valuable innovation should solve real problems. Graham believes that the best innovations often come from problems the innovators themselves encounter. When you encounter a problem and find that existing solutions are not good enough, this might be an opportunity for innovation. Innovators need to have keen insight to discover problems or needs that others ignore. They also need the courage to challenge the status quo and try new solutions. This problem-oriented innovation method is more likely to produce truly valuable innovations. The book tells the story of Paul Graham inventing the spam filter, which well illustrates the essence of innovation. Graham initially didn't think spam was such a serious problem. But when he realized that if left unchecked, spam could eventually destroy email, he changed his view. The author began to think about how to solve the spam problem. At that time, the mainstream approach in the industry was to use blacklists to block known spam senders. But Graham thought this method only addressed the symptoms but not the root cause, as spam senders could constantly change their identities. Graham proposed a new idea. Instead of blocking spam senders, why not identify spam through the content of emails? The key to this idea was using the Bayesian algorithm to analyze email content and calculate the probability of it being spam. This method proved to be very effective, and Graham eventually successfully developed the famous spam filter. This story teaches us that innovation often stems from a change in perspective. When people are used to looking at problems in a certain way, innovation often comes from adopting a new perspective. The key to Graham's development of a revolutionary spam filter was that he stepped out of the mindset of blocking senders and instead thought about the problem from the angle of analyzing email content. At the same time, this story also shows that innovation sometimes requires the courage to challenge mainstream views. At that time, the mainstream approach in the industry was based on blacklists, but Graham insisted on a completely new approach. It was because he dared to challenge the mainstream and stick to his own judgment that he finally achieved breakthrough results. This concludes the interpretation of this book. Let's review